Okay, retro goal, go guide, go control, gum. Go JY goe. Although humanity has always been fascinated by the moon, true scientific exploration didn't begin until the 1950s. That's when robotic spacecraft were first developed and launched by the USSR and the United States. In 1959, Luna 1, launched by the Soviet Union, became the first spacecraft to pass by the moon. A few years later, in 1966, Luna 9 achieved the first successful soft landing on the lunar surface. Then, in 1969, NASA's Apollo 11 mission marked the first time humans landed on the moon. Since then, many countries have contributed to lunar exploration with orbiters and landers, and by January 2024, 5 nations had successfully completed moon landings. Yet even with all these milestones, one part of the moon remained mysterious and largely unexplored: the far side. The far side of the moon has intrigued scientists for decades. It's the hemisphere that never faces Earth due to a phenomenon called tidal locking, which causes the moon to rotate on its axis at the same rate that it orbits our planet. This synchronous rotation means we always see the same face of the moon from Earth, while the other side, the far side, remains out of view. This hidden face is often mistakenly called the dark side, even though it receives just as much sunlight as the near side. For centuries, this remote lunar terrain was beyond our reach, until the modern space age changed everything. Thanks to technological marvels like the James Webb Space Telescope and deep space missions, we've begun to pull back the curtain on what lies beyond the lunar horizon. Whether you imagine the moon's surface as a face, a bunny, a toad, or something else entirely, you're always gazing at the same familiar side. So what stops us from seeing the other half? The answer lies in the moon's unique orbital dynamics and its deep gravitational relationship with Earth. When the moon is new and positioned between Earth and the sun, the side facing us is cast in darkness, while the far side is fully illuminated. Conversely, when the moon is full and opposite the sun, the side we see is brightly lit, and the far side sits in shadow. This cosmic choreography has kept the far side hidden for millennia, until the Soviets pulled off a major feat during the early days of the space race. In 1959, the Luna 3 spacecraft became the first mission to photograph the moon's far side. While Sputnik 1 was primitive by today's standards, Soviet engineers pushed their technology forward quickly. Just 2 years after Luna 1, Luna 3 gave humanity its first glimpse of the far side. It captured 29 images using film, which was processed, repaired, and dried on board, a significant challenge in space. Interestingly, the film itself was sourced from American spy balloons, chosen for its durability and radiation resistance. The spacecraft then scanned and transmitted the images back to the Soviet Union using a basic onboard system. Though only 17 of the 29 images were successfully sent to Earth, and just 6 were considered clear enough to publish, these photos changed everything. They revealed 70% of the far side and gave scientists a whole new perspective on the moon. Gone were the familiar dark splotches, called Maria, that shaped the man-in-the-moon image we see from Earth. These Maria are volcanic plains formed by ancient lava flows. On the far side, however, they are almost entirely absent. Instead, this hidden terrain is covered in craters, some the size of small countries. During the Cold War, the Soviet Union began naming and cataloging features on the far side, a move that stirred geopolitical controversy. Among their most significant discoveries was Mare Orientale, one of the largest impact craters ever observed. Though located near the moon's limb, this massive basin is technically on the far side and only visible from Earth during favorable librations, subtle wobbles in the moon's orbit. The crater, resembling a vast bullseye, was created by an asteroid impact nearly 4 billion years ago and later filled with volcanic lava, forming a striking impact basin nearly 900 kilometers wide, about the length of the United Kingdom. In 1965, another Soviet mission, Zond 3, further advanced our understanding of the far side. Equipped with better cameras and scientific instruments like spectrometers, Zond 3 captured 23 high-quality images that contributed to one of the first complete lunar maps. Meanwhile, across the Atlantic, NASA's Apollo program was gaining momentum. President John F. Kennedy had set an ambitious goal: to send a man to the moon and bring him safely back to Earth before the end of the 1960s. In December 1968, Apollo 8 made history. Astronauts Frank Borman, Jim Lovell, and Bill Anders became the first humans to orbit the moon and see its far side with their own eyes. During their mission, communication with Earth was lost for roughly 10 minutes as the spacecraft passed behind the moon. Mission Control in Houston held its breath during this blackout. Humanity had never been so far from home. The computer told us that we were out of contact with the Earth and that we had loss of signal, says Charlie Duke, the Apollo 16 lunar module pilot. Then all of a sudden there was the sunrise. It was the most dramatic sunrise I've ever seen. In Earth orbit, you see the sun's glow on the horizon or the planet's atmosphere and it gets brighter and brighter. But the moon is different. There's instant sunlight with long shadows on the lunar surface. The far side of the moon was very rough back there. I would not have wanted to land on the backside of the moon. 2 months before the dramatic landing of Apollo 11 in May 1969, Gene Cernan, John Young, and Tom Stafford were the next astronauts to explore the far side of the moon on board Apollo 10, which returned to low Earth orbit testing of the lunar module following the success of Apollo 8. However, during Apollo 10, the 3 astronauts saw something unusual while flying over the moon's far side. This encounter has caused NASA to re-explain in recent years because of conspiracy theory films that have been showing on US television since the 1970s. The facts have been widely known. Some really peculiar noises were the manifestation of these weird happenings on Apollo 10. Although cutting edge at the time, the radio systems aboard the Apollo spacecraft were outdated by today's standards. Most astronauts said that the command and lunar modules were noisy places, with loud bangs and bumps mixed in with the sound of fans and engines. The crew of Apollo 10 was confused by what they heard over the radios, although research has since shown that the sound was nothing more than an interference effect from those 1960s radio communication systems on board. They described it as sounding almost like the sound made by an electronic instrument called a theremin, which was often used in creepy science fiction B-movies of the 1950s and 60s, as well as in the Beach Boys song Good Vibrations. As the moon landings began, 2 astronauts descended to the surface, and the 3rd astronaut stayed in the command module to circle the moon by itself. The solo orbiting missions of Michael Collins, Apollo 11, Dick Gordon, Apollo 12, Stuart Roosa, Apollo 14, Al Warden's, Apollo 15, Ken Mattingly, Apollo 16, and Ron Evans, Apollo 17, were among the bravest feats ever accomplished by astronauts. Even though they all had the opportunity to orbit the moon and see the far side before landing, from orbit they would chart features that no one had ever seen before, spending days performing meticulous inspections of the moon. Al Warden's is frequently cited as stating that during the Apollo 15 mission, his alone time was among his best. As said by Warden's, the far side, the views at certain times when the sun and the earth are blocked out, are like nothing you could imagine. The sheer number of stars you see is incredible. It's like a sheet of white, and you know that every single one of them is a sun in its own right. Why all of the Apollo missions were limited to the near side is a subject that is frequently posed to the astronauts and flight crews. The solution is really easy to understand. If something had gone wrong while the astronauts were on the surface, they would not have been able to connect directly with Earth. As Charlie Duke states, we wanted to be in contact with the Earth. Nowadays this wouldn't be an issue, as communication could be relayed via satellites positioned in lunar orbit. Scientists are becoming more interested in the far side, maybe because of upcoming human trips. Yes, there are a lot of options for the moon's far side. The scientific and astronomical community has advocated for the placement of radio and optical telescopes on the far side for many years. Far-side observatories would be protected from both the glare of daytime on Earth and man-made radio interference from Earth. The telescopes would provide us an unparalleled level of clarity and understanding into the farthest regions of the cosmos if they were constructed inside craters to protect them from solar radiation. Furthermore, our comprehension of the mechanisms underlying the striking dissimilarity between the near and far side's appearances is limited. The rise in interest in lunar exploration is fantastic news for planetary scientists wanting to discover more about Earth's rocky buddy. And with NASA preparing to send people to the moon's south pole, there has never been a better moment to be a lunatic. They are eager to respond to these pressing inquiries. As a project scientist for the Lunar Reconnaissance Orbiter and research scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, Noah Petro states that, the fundamental question of how the moon formed and how that relates to the Earth is really the most important of the unknowns. Everything else comes after that. One of the most widely accepted theories for the moon's formation is the giant impact hypothesis, which suggests that the moon formed from the debris left over after a Mars-sized body collided with the early Earth. However, this theory still leaves many questions unanswered, especially when it comes to explaining the vast differences between the lunar near side and the far side. The crust on the far side is much thicker, and the maria, those dark, basaltic plains so prominent on the near side, are almost entirely absent. Scientists believe that by studying the far side more closely, we may uncover vital clues about the moon's history, its internal structure, and even the early days of the solar system. In recent years, several missions have started to shed new light on the far side. In 2019, China's Chang'e 4 became the first mission to successfully land on the far side of the Moon, touching down in the South Pole, Aitken Basin, one of the oldest and largest impact craters in the solar system. This mission not only demonstrated that landing on the far side is possible, but it also laid the groundwork for future missions, including those that could carry humans. With relay satellites like Keiqiao in lunar orbit, communication with Earth was maintained despite the Moon's mass blocking direct radio contact. Looking ahead, NASA's Artemis program and international partners are aiming to return humans to the Moon, this time to stay. Future missions may include bases or science stations on the far side, offering an unprecedented opportunity to study the Moon in its entirety. As we continue to explore, we're reminded that even the celestial body that has been orbiting us for billions of years still holds mysteries we've only just begun to unravel. The far side is no longer the dark side, at least not in terms of knowledge. What was once unseen and unknown is now becoming a new frontier for science, exploration, and maybe even long-term human presence. In the coming decades, the far side of the Moon could be transformed